Okay, so this is lesson 2, and we're going to start with a warm-up. So angle 1 is a complement of angle 4, and the measure of angle 1 equals 33 degrees. Find the measure of angle 4. So what that means is, remember, complement, we always should think of 90 degrees, okay? It's going to be a right angle. To complement someone is the right thing to do. So angle 1 and angle 4, when you add them together, are going to give you 90 degrees. So angle 1 plus angle 4 equals 90. We know that angle 1 is 33 degrees plus angle 4 equals 90. Now all we have to do is subtract 33 from both sides. And we get angle 4 equals 57 degrees. Number 2, or 26, or let's go to 25, sorry. Angle 3 is a supplement. This is 24, 25. Angle 3 is a supplement of angle 2. And the measure of angle 2 is 147. So we know that angle 3 plus angle 2 must equal 180 since it says supplement. And from here we have angle 3 plus 147 equals 180. We subtract 147, subtract 147, and we get angle 3 equals, this is going to be 3, this is going to be 33 degrees. And then number 6, name a pair of vertical angles. That would be angle 1 and angle 3. The reason they're vertical is because they share the same, their lines, or their sides are the same lines, okay? So this is 25, 26, angles 1 and angle 3. Point 6, prove angle pair relationships. All right, so let's get started with our next section. So flowchart and paragraph proofs. Again, we are only going to be dealing with 2 chart proofs in terms of creating our own. We won't be writing flowchart or paragraph proofs, but we need to know what they are. So up at the top, I want you to write, we will not write flowchart or paragraph proofs, but know what they are. Okay, so a flowchart or a flow proof, it uses boxes and arrows to show the flow of a logical argument. So it's kind of like you'll see a box, then an arrow, then a box, and then maybe an arrow down here, and then another box. And then the paragraph proof represents the statements and reasons of a proof as a sentence in a paragraph. So it just kind of looks like a paragraph that you're writing out. And it's got all the statements and reasons. It's just not organized like a 2-column proof is. All right, theorem 2.3, which is the right angle congruence theorem, that states that all right angles are congruent. And when we are talking about these theorems, this number right here, 2.3, is not important. What's important is the name of the theorem. So it's the right angle congruence theorem. Okay, this is an example of a flowchart or a flow proof. Again, guys, I am not going to expect you to be able to write some of these. I just want you to know what it looks like. So the actual proof is down here. So it says angle 1 and angle 2 are right angles given, and then it leads into the definition of a right angle. We can write measure of angle 1 equals the measure of equals 90 degrees, and the measure of angle 2 equals 90 degrees. And then it leads into the transitive property of equality, where we can write measure of angle 1 equals measure of angle 2, and then we can write that angle 1 is congruent to angle 2 by the definition of congruent angles. Okay, so that was the flowchart proof and we proved the right angle congruence theorem. All right. Okay, so more on the right angle congruence theorem. All right angles are congruent. Given angle 1 and angle 2 are right angles, prove that angle 1 is congruent to angle 2. We just did this, so we're going to explain it with reasons, okay? So angle 1 and angle 2 are right angles. That is what's given. Measure of angle 1 equals 90 degrees. Measure of angle 2 equals 90 degrees. That will be the definition of right angles. Measure of angle 1 equals measure of angle 2. We said that was the transitive property. Or you could have said that it was substitution, because you're substituting in either measure of angle 2 for 90 degrees or measure of angle 1 for 90 degrees. And then the last one, which is D, is the definition of congruent angles. Okay, now that we've proven the theorem, you guys can just use it going forward. So if it says that the measure of angle 1 and angle 2 are right angles, you can just say, by the right angle congruence theorem, angle 1 is congruent with angle 2. All right, 2.4, so congruent supplements theorem. This theorem states that if two angles are supplements to the same angle or to congruent angles, then they are congruent. So if angle 1 and angle 2 are supplementary, that's these two right here, and angle 2 and angle 3 are supplementary, that's this one and this one, then angle 1 is congruent with angle 3. And that makes sense because if measure of angle 1 equals, or we'll go over why that makes sense. We're going to prove this one. So this is an example of the congruent supplements theorem, and we're going to put the reasons behind it. So this was considered the given. From there, they wrote that the measure of angle 1 plus the measure of angle 2 equals 180, 3 and 2 equals 180. That is what's the definition of supplements. Or supplementary angles. Next, measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. That's also transitive. So from getting from this step to this step, there's actually two that you could have put. You could have put transitive or substitution. Either would have been fine. Measure of angle 1 equals measure of angle 3. All they did was subtract the measure of angle 2 from both sides. And that would be subtraction. Property of equality. And then angle 1 is congruent with angle 3. That's just definition of congruent angles. Okay, congruent complements theorem. So if two angles are complements to the same angle or two congruent angles, then they are congruent. So if angle 1 and angle 2 are complementary, and angle 2, angle 3 and angle 2 are complementary, then angle 1 is congruent with angle 3. That one's the exact same as the supplements theorem. So all we need to do is prove it the same way if we were going to prove that one. And postulate 2.8, so linear pair postulate. If two angles form a linear pair, then they are supplementary. So angle 1 and angle 2 form a linear pair, so angle 1 and angle 2 are supplementary, and measure of angle 1 plus measure of angle 2 equals 180 degrees. That one should be pretty straightforward. And we've also got vertical angles definition. Two angles such that the sides of one angle are opposite rays to the sides of the other angle. Again, we just did one like this in our warm-up. So angle 1 and 3, see how they share the same line for both of their sides? those are considered vertical angles, okay? And so 1 and 3 are vertical angles, and 2 and 4 are vertical angles. This should be kind of like a review for you guys. All right, theorem 2.6. Remember, 2.6 is not important, but the name of the theorem is important. So vertical angles congruence theorem. So vertical angles are congruent. We already knew that. Okay, they're going to be the same measure. They are going to be congruent. All right, so paragraph proof for the vertical angle congruence theorem. This is what a paragraph proof looks like. Again, I'm not going to require you guys to be writing any paragraph proofs, first of all, because they're ugly, and also because they take a lot of time. And why not when you can write the pretty little 2-column proof, okay? So we will be writing 2-column proofs. You need to know that a paragraph proof looks like this, though. You need to be able to read one, okay? So if you were to read through this whole thing, it would say every statement, and then it would be followed by the reason, okay? So if anything was given, they would say as shown in the diagram, or this was given, and then they would just keep writing, okay? All right, so we're going to prove the vertical angle theorem, but we're going to use a 2-column proof. So in this one, the first statement, which is angle 5 and angle 7 are vertical angles. We're going to go ahead and write that that is given. 5 and 6 are a linear pair, and 6 and 7 are a linear pair. That's the definition of a linear pair. Three, angle 5 and angle 6 are supplementary, and angle 6 and angle 7 are supplementary. Remember, we just went over that one. That one's called the linear pair postulate. Okay, any 2 angles that are a linear pair are supplementary. And then we get to our final one by the congruence supplements theorem. And that one we already proved, but it basically said that if angle 5 is supplement with angle 6 and angle 6 with angle 7, then angle 5 and angle 7 must be the same, because both of those are adding up to 180. All right. Example 6, find the value of x. So we know that this angle right here is a vertical angle with this one. So what we can do is we can take 3x plus 1 and set it equal to 148. Why? Because the measure of angle QPR must be equal to the measure of angle TPS. So then from here, we're just going to subtract 1. 3x equals 147. Divide by 3, x equals 49. Okay, vertical angles are congruent. All right, example 7, classify each statement as true or false. If the measure of angle A plus the measure of angle B plus the measure of angle C equals 180, then angles A, B, and C are supplementary. This is false. Okay, only 2 angles can be supplementary. Only 2 angles can be supplements, okay? Next one, vertical angles have the same measure. That one is true. Always, okay? So they're not vertical angles if they don't have the same measure. And if measure of angle 1 and the angle 1 and angle 2 are vertical angles, measure of angle 1 equals that, measure of angle 2 equals that, then x equals 14. Well, we can find out because the measure of angle 1 should be equal to the measure of angle 2 if they're vertical. So 2x plus 8 must be equal to 3x plus 4. We can subtract 2x and subtract 4 from both sides. This will get rid of that and that. And then we're left with 4 equals x. So this one is false. All right, cool. Those were the end of the notes. And here's your homework. Good luck.